Welcome to User Scale Models. I'm Jason, your host. I do models and electronics. But electronics, that's weird. Anyways, and I fixed some Nintendo Switches. What is up with that? How is everyone doing today? I just gotta send out a message here about this. Alright, so today I talked about I would possibly do a Saturday stream because I'm taking next week off and I have a addiction apparently to my channel that I can't take a day off. But we're gonna do something. I don't have a lot to do. I don't have a lot to work on. We'll go ahead and go to the bench here. Not this cable. We're not working on that cable. I have a lot to work on. I do not have a lot to work on because I am still waiting on parts from AliExpress. I'm still waiting on something from eBay, and I have a few things that I need to get done, and I plan on doing that on a stream on November 30th on my birthday. When I come back to streaming, this is technically not next week, so I can do it on today. But next week I am doing some other things. I may stream some gameplay. I was told I'm allowed to do that. But what I am going to take a look at here is this is the battery charging circuit for the battery. This is pretty much shot. Can't get it to work, so I am going to make a cable that plugs into my power supply that I can power the Nintendo Switch with, and we hope that works. So I'm going to make a very simple cable here that will do that, and then we can talk about it or do whatever you want to do. So that is what we are going to do. Alright, let's see here. Let's cut this cap down tape off. This is definitely a weird circuit. Okay, so alright, so we need to desolder these wires, and that's what I'm gonna do now. Get into the view. That's, man, that is in a bad spot. Okay, so this is in view for you guys. And is that in view? There we go. And let me focus that a little bit better. Alright. Okay, so that has been focused better. So let's get the soldering iron fired up. I'm going to use a TS100. I'm going to turn it on, and I am going to, should fire up to its normal temperature, which should be enough to melt these wires off here. Is it going to go all the way, get all the way to 400? Yay, it made it, and it's going to keep going. Thought it was set to 400, but it's definitely set to 450. Pull that one off. We're going to pull this one off. Try to get these apart here the best I can. I do want to get these wires off the board too, so there's that. So there's that off of there. Let me try to get this off. Almost. There we go. We got those off of there. That's what I was looking to do. Clean my iron tip. And this board is done. Let's take a look at what we have here. Now, so we got 2 sets of wires here, 2 sets of wires there. I'm pretty sure they're all common on here, so. Yeah, it looks like they're all common down there, so what I want to do is I want to take whatever one of these wires I can get off, and I want to solder them on to the AR. How's it going? Our wheel. I want to get these wires off and solder it onto those little wires, plug it into my power supply and go. I was going to do something fancy like hook it up to the electronic load and a bunch of meters to get the exact current reading and electronic load reading, but it doesn't need that. I can hook it up to the load and draw 5 volts and get the charging and check the charging circuit. I normally always wrap my wires, but I'm not going to wrap these. I'm going to leave them unwrapped just because it's easier to work with and slide on heat shrink and stuff. Alright, so that's that wire wrap out of here. We're going to get that wire out of here. And we're just going to use these 2 here. So now let's see. Let's get some heat shrink and see what mess we can get into with heat shrink here. If I would have thought this out ahead of time, I would have gotten some heat shrink out. There's the heat shrink. Okay. So this is my bin of cut heat shrink. This should be 3 times. Oh no, this is 2 to 1. So when it was my 3 to 1, but so I have some stuff that will fit over these here. It should melt down. I'm gonna need to trim this a little bit. Just a little bit there. Take off the same amount on the other one so they're still even. So, alright, let's strip this wire back. It's more than I need, but we'll deal with it. Oh, I'm making a cable that plugs into the power supply and then plugs into the switch to mimic a battery. So that's what I'm working on right now. I'm just gonna make a simple one, and if it works, I will make it more elaborate later. I just none of my stuff has come in for the channel, so I really didn't have much to work on, but I still wanted to stream. So I just figured I would stream this and see what happens. I was hoping for some tools to show up or some parts, but that is not what happened. And those Zuron cutters are about on their last leg, so that stinks. Alright, so if I take this black one, let's see if this black one is small enough. So I want it to be a tight fit. Yeah, that could work. If I take that, I take these wires. Stuff them in there, get them all in there with hot solder, and then solder that up, and then heat shrink it. That should work. So let me get the helping hands. Have some coffee first. Alright. So heat shrinks on. That's good. Iron should still be good to go. What I like to do with this wire, because it's so crappy, I like to put a little bit of flux on it, because my solder is so thin that it doesn't have enough rosin in the middle of it to really tin the wire correctly. Yeah, that Amtech stuff I'm not a fan of. Okay, so I will grab these. Okay, I believe that one is soldered on there. Yep, that one is soldered on there. So, take that out. Slide up the heat shrink. Well, I need a little bit of room on that, so slide the heat shrink to there. Well, we might as well heat it up here. Let's put the air down to that. Oh, I'm sorry. I'm probably not doing that on camera. Alright, so that's that. Alright, that'll work. Okay, so now we have to get this gray wire out of here. We have the red wires to do. So let's put that on there, and this time I'm going to use a little bit of this flux here. It's not as bad as the other stuff. So, hey Mike, how's it going? Of course, the iron went to sleep. Yeah, we're just making a cable for the switch. That's what we're doing. This is all wonky on me. Oh, that got really hot really quick. Alright, so that's on there finally. That was. And I forgot to put the heat shrink on, so we're going to take that back right off. And I got it on there. And we're going to make make sure that's not too hot. And we're going to slide the heat shrink down because you can't forget the heat shrink. Hey Pete, how's it going? We are making a cable for a Nintendo Switch. Yeah, it's not quite scale model related, but it is part of my learning of electronics. This is kind of like cable 101. You should always know how to make your own cables. Alright. This one was giving me a little bit of an issue here. So so that will go out right there. And we will heat this up. And I don't want to forget about this gray wire, so I'm going to stick that on there because I am going to not use it in the beginning. So I'm just going to put this on there real quick. Okay, so there's the heat shrink done. I'll put this away. Alright. Twist heat. Yeah, I wasn't working the way I wanted to, but I got it on there. It's working now. Yeah, I was twisting it and I was holding it. I had it twice and then I burned my fingers because the wires were so thin. So that made me let go and drop it. So, but this should be good. We can check the continuity between the connector and the plug-in. Turn off the fume extractor. So we will check the continuity of the connector as soon as the meter comes on. Now you're just going to hear it beep because I don't have the software running to make it on the screen. This is supposed to be a lazy stream. I just turned it on. I'm going to attempt to stream a video game. Yeah, Pete. The Yag Tiger's on hold because I lost my paint station. I had a whole section to my right, and it's about, I would say, 4 foot by 3 foot, and then an area that is about 20 inches tall. I had a whole area like that for my airbrush studio. It had exhaust and all kinds of fans and everything, but that's where my son moved in for at-home learning. So until he goes back to regular school, I'm not building any model that needs to be painted. So I'm just doing the electronic stuff here, and then I can get back into painting then. Okay, so there's no connection between the two, so let's stick a probe in this black one here. Okay, that one's good. And now let's check this one. And no continuity between any of those. Okay. So, in all theory, I should be able to take a pair of connectors out of here. This one and this one. And plug it in here. Plug it into here. Okay, let's see here. Let's turn on, I'm going to actually put some stuff on the screen now. Heat sinks for diodes. Yeah, the King Tiger is nice on. I like the Ag Tiger, but I wish they would have just redid all the sprues because they are old sprues and there's a lot of cleanup and a lot of gaps to fill in that. But all in all, it's a good kit. It needs a lot of modification, and I'll be doing that again once I have paint. Then I can start doing that again. Otherwise, I live in Florida, and it's so humid out, I can't paint outside. So until I get my airbrush studio back, I can't paint anything. So everything, all my models and all my paints and my airbrush stuff is all packed up at the moment. It's all packed up in the garage. Okay, so... Alright, so I can put the power on. There we go, 4.2 at half an amp. Okay, so we have that plugged in, and we should have 4.2 volts on here if I turn it on. So let's turn that on. Let's go to voltage, and we might as well connect that. And of course it's there. Of course. Why wouldn't it be there? Okay, so there's the meter. So we're going to check this here to make sure everything works. Yep, 4.2 volts. So that seems good. So it's putting out the correct voltage. Let's grab this switch here and see what we were doing. This switch has a ground wire attached to it because I was doing a lot of capturing with the oscilloscope and I needed a permanent ground. So yeah, this one has a lot of different has a ground bar on it for me to test different signals and whatnot. I gotta find my cable. Here it is. So no, I really don't have a way to know if this works unless this power supply draws current. Let's see. I got it set to 500 milliamps. It doesn't draw anything. So let's see what happens when we wake it up with a charger. So it still doesn't draw anything. What if I lower the voltage on channel 2 to about 3.6? Oh, see, this is not even charging now. See, I didn't think it would charge without this gray wire attached. But it is definitely supplying power. So I couldn't theoretically connect this to a screen and power switch on. But I don't have one currently I can do that with. Because the one I do have is needs trace repair on P13. So, but the cable is made. It didn't mimic the battery as I thought. I'm going to have to inject the signal from the signal generator into this gray line that's left on here. So I'm going to have to run a cable off of here to my signal generator and just generate the pulse. I'll copy the pulse from a good battery, and I'll just copy it and on the oscilloscope and upload the waveform into the waveform generator, and then just do it that way, and then just tie that to this line. I'll put another cable on here that I can just plug into the signal generator. So, but I wonder if this will actually supply power to the switch itself to turn it on, but I don't have one to do that with. The only one I have that I know works needs P13 trace repair, and I have already pulled the P13 off, so it won't work at all. So I got to fix that. So, hey Micro Mage, those meters are unreliable. Crocodile clips, yeah. These meters are crap. This, if you're Micro Mage, if you're referring to this meter here, yes, this meter is crap. It's very inaccurate, but it does tell me if it's charging or not, or if it's drawing zero current, because I know how much it's off by. I tested it. Yes, I am not happy with that meter at all. I'm not happy with that meter at all. So I actually made a power supply from my power supply to the charger, and a way to jump the current to do it. I'm still working out all the kinks on the cables, but I'm basically going to tear apart a OEM Nintendo charger and run the main line through the amp meter on the bench, and then I can see how much current is drawing directly. So, but when I get a switch that works, and I'm going to try to turn it on with this battery clip right here, just to see if that works. Just to have a cable. I didn't initially plan on doing this. This is just none of my stuff arrived, so none of my stuff has showed up yet, and I'm taking next week off. So I didn't really have anything, and I just wanted to get this last stream out there. People have commented and stuff saying that they want to see me stream a video game. So I will be playing Borderlands 2 on stream with my son. He's 13. We love Borderlands 2. We play the game together all the time. And we have some level 72 sirens, and we're trying to get them to level 80. So we're going to either get them to 80 and then stream it, or stream us doing some level runs and then farming some gear, and then like doing Digistruct Peak or something. It won't be every day, and I still need to test the system out on here to see if I can actually capture the Switch in docked mode and stream it to the stream with audio. I've never done that before, but I'm sure I can figure it out. I was hoping to do it at the end of the stream to test it out, but it's only 5:30, so my son's not going to be up yet. It's an early day for me, so not as early as normal, but an early day. Oh, hey, Micro Mage, while you are in here, let me ask you a question. Where did I put that in the wrong box? You sent me a message about some components above and below M92 here. Let's get the microscope here. Let's close that one and get that one. Okay, let's get the microscope. And let's Okay, so were you talking about this PP5743 and then this KO3 chip? Is that what you were talking about? Yeah, because that's the only 6-pin chips I see. No, between M30 in the port. Oh, are you talking about this on this film? Oh, that's not it. That's this right here. It's not the best picture. Why does that not look right? So, are you talking about this here? Okay, right there. Okay. Interesting. Well, let's test that and find out what we have here. Let's go to... See, this turned into actually, I'm kind of interested about this. Oh, the other one is on the other side of the port? See, that's where it confused me. Is this it right here? Oh. Now, is this the one right here? Here's the port, and there it is right there. Yeah, the circuit definitely took a hit when I shorted it out. So let me check those. Let me start with this one here. So I'm going to put my red probe on ground, and so, well, actually I just want to check this way. And I can't see. So I want to check. This is where my new tweezer would come in handy. Okay, that's open. That gives me a diode. Don't disregard the beep, guys. I have my threshold set up high for a reason. I can turn the beep off and we'll just look at the numbers. So, 7.8 there. And open. So if we go the other way. These are one. Okay, are these diodes or transistors? They're definitely not reading like diodes. They're reading like transistors. Okay, so let's see. So this should be base to emitter. Nope, that's base. Okay, so that's base to emitter, and I got the probes backwards anyways. So if they're transistors, this is base, this should be base to emitter, should be a diode junction. paste to emitter. Should be a diode junction, and it's 4.9. And then this should be open because it's the collector. So if I come to emitter collector, I should have a, if that is actually, it is a diode array? Okay, because I'm not reading it as diodes. So I'm getting open line. Getting a diode drop there. What do you replace these with? Do you replace them with from donor boards, or do you have a part number for these? Because they tend to read like transistor diode arrays, the Darlington pairs type of package. Oh wow, you actually got a part number. Oh, Micromage, you are like #1 in the group now. Let's go to DigiKey. And of course that didn't work. DigiKey. DigiKey. Okay, let's go to monitor 2 and let's paste that part number in there and see what they have here. Okay, Texas Internet, OMG, it is a diode array. Trans voltage suppressor diodes. These look exactly the same. 1/16 cents. Oh, of course, it's out of stock. Okay, what about this one? Of course, that's in. How much for 100 is? I don't want 100. I will get 50. How much is 50? That's like 22 bucks. Alright, so I got that in there with my fuses. I'm at $38 in my cart. So that is about where I'm at on the fuses. Let me check there. White order that. Where is my chat? Oh, that's okay. Hold on a minute. Let's go back to there. Okay, so showing things I shouldn't be showing. Pulling a fill. Okay, there we go. So, yeah, I see that they are TV. Yeah, when you said diode array, I had no idea what you were talking about, and yeah, I couldn't believe that they have them all later ones because they actually. Yeah, that is strange on that, but let me go back to. Oh, not this one. This one. Do they have a data sheet for this part? It's a 2.5 amp clamp diode. But I see what you mean, that it would go bad on those chips. Let's let's go. Here, actually, we'll go down here. And I found the data sheet for it. So let's go to this one this time so I can't show anything. And then I can't. Oh, my chat's still down here though. Okay, let me drag my chat up here. Okay, so there we go. Yeah, this one I got the data sheet off of this one. I just want to check it out here. So provide system level ESD protection for low voltage I/O interfaces. Yeah, that makes sense. Gaming machines, ebooks. So it does seem like it would be a portable thing. So, oh, it's that type of circuit. So you have your data lines, and I'm assuming your output would either be any kind of surges would be not allowed to pass either way through the diode array. Any kind of back feeds. Do they have a pin out? Here we go. So, okay, so testing them is not going to give me I'm not going to get a reading testing them because it's basically two diodes in the same, one facing each other. Yeah, I could see that. Yeah, I order from DigiKey just because of the ease of it. I use an account for my old job, so anything over $25, I get free shipping, and I get it the next day. So if I ordered it right now, I would get it on Monday, of course, because it's the weekend. But I get it the next day, and I just have to go pick it up. So, yeah, see, with this array here, there's really no way to test between pin 1 and... What does pin 1 and pin 5 give us here on the... let's go back to the main overhead view. What does pin 1 and pin 5 give us? So assuming that this is pin 1 and pin 5, that gives me a diode drop. And what was the other one? This one. And this one. So that gives me a diode drop also. These two should be no connects. Yeah. So, nothing from there. Okay, if they're on the ground side, that makes sense. So this one and this one should be... Let's see if we can make this easier here. Okay, there we go. We got the drawing. Of course, it's right over where I'm working. Oh, no, I'm good. Okay, so if we look at pin 1 and pin this one, we get 1.23, but if we go to the next set, we get 0.4. So this is pin 1 here. So to this one, I get the voltage drop that I was looking for. Now what about this one? Is this going to be that reverse stuff? Yes, it is. Okay. So that makes sense. It's a set of diodes going one way and a set going the other way. So that one seems good. Let's see if we can't find the Hey Phil, how's it going? I was just talking to Micromage, and these are diode arrays that he was talking about. There's one right here next to the port, next to FY, and there's one right here next to FL1. These are diode arrays. I found the data sheet, and I found the part number, or he sent me the part number on, and I found them on DigiKey, and I have the data sheet, and that's what's on the screen now. So I was just testing their EST protection diodes. Apparently, he was saying they're only on this revision of the board, but they're cheap. I'm going to get me some. Okay, let's go to application information here. Okay, well, this just shows them being used in an audio circuit. Huh. Wonder why they would have one doing power. Let's check out the application curves. Okay, that's just how to lay the chip out. It's weird why they have it on a audio application. When a system contains a human interface connector, the system becomes vulnerable to large system level ESD strikes that a standard IC cannot survive. TVS suppression diodes provide a typical use to suppress ESD at these connectors. So it provides a current path to ground. That is strange. So, look at that, EST diodes, check that out. Hey Andy, how's it going? Alright, yeah, I look on DigiKey, I found some, I already have some things I need from DigiKey, and I needed to get to $25, so I'm going to order some, but I don't know, I tested it, it tests weird for having the schematic the way it is with the diodes like this. I shouldn't be getting, I mean, in theory, I shouldn't be getting voltage drops either way, because if I measure two diodes facing back to back, I shouldn't get a diode reading between them. But let's find out if that's true. I'm going to take this off, and we're going to do a test. And I want to see how one of these diode arrays would work. So what I'm going to do is I'm going to get some diodes here. Grab these two diodes. And I'm going to point the two little things in together. The two little lines, the negatives, just like it is on the schematic, and I am going to see if I get a diode drop across those. No, I don't. Didn't think I would. Okay, so even if I reverse it, I'm not going to get a diode drop across that. Yeah, no, I didn't think that would work. Okay, so this is weird that I would get a reading across those because of the way that they're designed. If you look, let's go back up to the top. Yeah. If you look, that's how it is in the chip. It's very strange. A lot of curves and graphs. But if that's how it is in the chip, you shouldn't get a reading across to 1 in 5. Shouldn't get a reading across 1 in 5. And I do. I get a reading either way, like it's only one diode. So, hey, my damage. Oh. Oh, I don't know. I made that cable earlier. I've lost the cable. Oh, here it is. I made the cable with the battery connect. Wow, that's still on the screen. I made the cable with the battery connector on it, and then I saw that Micromage was in here, and I asked him about these, what the 6-pin diode packages he was talking about, and it turns out they are 6-pin diode packages, and they are for ESD protection. I found them. He gave me the part number, which I greatly appreciate. Thank you so much. Always count from the gold resistor on the strip. Okay. So yeah, that's what we have here. I'm going to attempt to try to check these the same way. Can I see the dot? Yeah, the dot is up here. Pin 1 is right here. And pin 5 is right there. And I get the same reading I got on the other ones of 1.3. And if I switch my probes, I should get a proper diode reading. Yeah, 7.8 is kind of high. The other one read lower than that. One's 1.3 that way. That one's reading a little high in one direction compared to the one on the back. But, yeah. Yeah, I will do it too. Micromage, I will sub to your channel too. I definitely want to see this fault. No, Coder, here, I'll put up the sheet again. That's supposedly the chip. It's two diodes facing each other. Yeah, it's weird. Yeah, it's a weird one. I'm not sure. And if it's two diodes, and I just tested two diodes facing each other, you won't get a diode reading across them. And I'm getting a diode reading like it's one diode. So I don't know if they use a specific type of diode that allows things to pass at certain levels. So I'm not sure. I just put them on DigiKey, so I will order them when I'm done with this stream. I'm going to order those and those fuses I got to test those out. Apparently they're only on this revision, so I'm not going to keep a lot in stock. I'm just going to get a few, just enough to get me to $25 on my other stuff. And I also need to squeeze in these MOSFETs here. I want to find these, so if anybody knows the part number on these MOSFETs, because searching on by what little bit is on there, I cannot seem to find them. So, and I make part lists available publicly, so. Okay, let's get this off of there. It's been up there long enough. So that appears to be these two packages, and you know, see, it's on this set. It's over this set of data lines, which is. Oh, you know what? I get it now. Hold on a minute. This just occurred to me. If you look at the same area of the board, they're missing. So that's why I'm getting a diode reading. So this is what the tracks look like under that chip, because these boards do not have that chip. I thought they redesigned the board and they just left them off, or they just pulled them out of the board design, but they just left them off altogether. I wonder if that has any significance of performance issues for the protection, ESD protection. But yeah, earlier revision has that on there. Yeah, that would be great, Phil. Okay, in the circumstances that everything else seems right, you have changed all the blown parts in the circuit. You should get a duct sync or one side charging. Yeah, there's always going to be these guys. Yeah, um, I'm gonna order some just to have, because I like to have parts just at hand, and I want to compare them and see, um, and put them on, and I also want to throw them on the old board, new board, and see if they still work, just to see, because I do weird things like that. But yeah, I will do that. If I order them on DigiKey, they'll be here before the 30th, and I will I will change them out on a stream with the other stuff I'm doing that day. So, but that is all that I have for you here. Oh, hold on. Why did photo etching on? Okay. By the way, did you know you can inject voltage into these from a fuse? It must need USB detect to send the signal to wake up the PMIC. Yeah, but there's ways to inject voltage with a signal with a carrier signal. Um, um, yeah, so. Alright, Micromage, take care. Thank you for your help. I appreciate that part number. Um, yeah. Yeah, see, you can't inject it through the battery either because it needs that gray line. That's what I discovered earlier. If I just plug this in without that gray line connected, it doesn't even recognize that a battery is connected. It doesn't even recognize it. And that was the issue I had with the thing. So what I'm going to do is I'm going to copy the signal from a normal battery when it's connected and just pump it in with the signal generator and see what happens. But that is for another. Yeah, I might need to get you to record that signal so we can do it. Yeah, that shouldn't be too hard with the oscilloscope I have. Actually, your oscilloscope that you just got, that should be able to record a signal and play it back. From what I looked up, I looked it up to see if I could learn anything about it to help you in the future. And it does appear that it can input and output a signal, and it can record something and output what it just recorded. And at 5 volts, with the switch running on 5 volts, 4.2 volts, 3.8, whatever the battery voltage is, a signal generator has no problem putting out that amount of voltage. It can't dump a lot of current, but on a data line or a signal line, it's not a lot of current that is being used. So you can use a signal generator for things like that. Actually, what I found out so far, the signals on this line are in the 2.38 volt range, so very low signals. That's why we need the BEQs here for the test kit. Yeah, yeah, I believe it can. It supports micro SD too, so yeah, that's how my scope works. I can plug in a USB cable, copy the signal, and then I can plug that USB into my waveform generator, and then just load that signal, and then I can put that exact signal out. My problem is capturing the signal at the correct resolution, because I could capture a large portion of the signal in a lower resolution. Then all I really need is the peaks, the on times, and the frequency, and I only need to capture about 3 of the signals itself on the whole line, and that would give me the max resolution I could get to copy that, transfer that to the signal generator, and then just replicate that. So, but my problem is, it's like 3 pulses and then nothing for seconds. There's seconds in between the 3 pulses, and then there's milliseconds in between the 3 pulses. Then there was a few seconds in between the next 3 pulses. So I would need to capture 2 sets of those 3 pulses if there is that time delay in between to absolutely replicate that time delay. Yeah, I would try it, Phil. Just try to make it. Yeah, I mean, test leads are fun. I like these ones with shielded connectors, and then I put adapters on it if I need to go into banana jacks. So yeah, they're easy to make, and it works out. And then I use this wire I got off Amazon. I love it. It's 16 gauge ultra flexible silicone wire. It's super soft, super flexible. It doesn't burn. You get 25 of each color, and it was pretty cheap. Comes in a nice bag. I wish it came rolled up on a thing, but I just throw it in that container that's unlabeled. So it's in the unlabeled container. Yeah. Yeah, that's good wire. That's the best I found on Amazon. I have bought many other types of wire on Amazon. Here's why I like this wire. It feels nice. It feels high quality, but if you look at this here, I will strip back a little bit of this black one here. I know that's copper. So look at it here. See, that is pure copper. That is nice, clean copper. So that takes solder beautifully. I love it. A lot of the stuff that you get on Amazon will say it's pre-tinned, or it's not even copper. It's aluminum, even though it says copper. But this stuff's nice because I know it's copper. It takes solder beautifully. It makes great cables. So this is the stuff that this is the stuff I use for making cables. And for the voltages we deal with, it's plenty At 16 gauge is fine for what you need. You're not going to have much of a drop, and if you keep your cable short enough, you're not going to have that much of a voltage drop, and you're not pulling enough amperage to kill that cable anyways. So, yeah, you'd be fine, as long as you're not drawing 10, 15 amps. I don't know what the rating is on this. Does it say? Oh, that's strange. It doesn't have a... It's rated 600 volts AC. So, there you go. I think you'd be fine. Yeah. Yeah, I like it. I'm actually going to get a couple of smaller sizes from them one day. But I recently just... Yeah, no, I didn't say 10 amps. I said 600 volts AC. Don't put 10 amps. Wait a minute. The speaker wire I use can handle 10 amps. Yeah, I'm pretty sure this cable is rated for about 25. Let's see if it says it. Well, let's see here. We could figure this out. Let's do... Let me go up here without showing any information. Let's do 16 AWG. This should give me... No, I don't want to buy any wire. Why do you tell me... Oh. Why do you tell me I want to buy wire? 16 gauge copper wire specs. Here we go. American wire gauge chart. Okay, so 16 gauge wire has a cross sectional of 1.31 millimeters ohms per 1,000 feet. So if I get my calculator here, and I go, what is that? 4.016 per 1,000 feet, and I have 2 feet, say, so we'll divide that by 500. Okay, so 0.0, so 8 microamps is what that would, or 80 microamps. Oh no, that would be 8 milliamps. Milliohms, 8 milliohms. Well, I just lost my brain there for a second. So if we take 8 milliohms and we times that by, let's say the typical system is 18 volts. So let's take point. Oh, here we go. So, I'm in scientific mode. I hate that. So, I have to write this down now because this is going to irritate me. My son was messing with the calculator for his school, and so if I have 4.462, and I move it 1, 2, 3, 4, So at the 2 foot at 18 volts, the actual wires would draw 0.4 milliamps. So I know engineering notation in threes, not these fours. That's just, why is it in scientific? I don't know. So it would draw 0.4 milliamps at 18 volts on that wire. So yeah, so it's not gonna really matter how many amps you could draw on there. It's gonna be able to handle the amperage on it because it's very low resistance wire. Um, Now, if you are measuring a dead short, if you're injecting voltage at a dead short and you put 25, 30 amps through the leads and the board is soaking it all up, the microamps that you have in the cable could heat up and could warm that up, and that could give you issues, but I don't think, yeah, 13 amps. I don't think you're definitely gonna be fine. You're not gonna draw any more than that. You're not gonna be able to. You'll be able to handle 13 amps. You can't draw more than 13 amps over there, anyways, can you? Yeah, you can have voltage with tiny amount of amps, and you can have a lot of amps and a little bit amount of voltage. It depends on the conduit and any kind of resistance in the way of the circuit. Resistance is what gives you current flow, gives you the variation on current flow. So whatever voltage you have is divided into the resistance of the circuit. So the higher the resistance in the circuit, the lower the voltage, the lower the current will be, and the lower the resistance in the circuit is, the more amperage uh, you get. Yes, that is true. Amps kill, volts don't. But um, extremely high voltages at low current can kill you. I watched a video the other day of them using glass as a conductor at super high volts, very low amps. It was like a tenth of a milliamp. So I think it was like 10 microamps of power, but hundreds of thousands of volts. And they were using glass as a conductor, and it lit up. It was pretty cool. It was for one of my classes I'm taking. But yeah, voltage is high enough can hurt you even if it has low amperage. Voltage is the carrier liquid that brings the death. So, let me get some of this stuff out of here. Okay, well, this got into a whole thing about Ohm's Law and all that good stuff. Oh, a little educational lesson. So, yeah, that 16 gauge wire, if you have 2 foot cables, even if you have 6 foot cables, you're looking at 12 microamps is what you're going to draw. So, the resistance is going to be minimal on that. So, I wouldn't worry about 16 gauge is plenty. I have some a heart. Yeah, but I mean they use high voltage to shock your heart back together, and it doesn't hurt you. Um, like I said, high voltage. I mean, it has to be pretty high voltage to take you down. But in high voltage like that, it's normally burns that happen that injure people pretty bad. You normally get severe burns and things like that from the voltage. I personally have never been up close to anything higher than like 400 volts from a fluorescent light transformer. So maybe 800, but that's, like I said, it's low current. So I've never really worked with that, and I mostly worked with power supplies that dealt with the uh, DC side of it. The power supplies we used were all standard based on country of origin because of regulations, and then the rectified voltage would then be gone through a different type of DC to DC converter to clean up the noise and give us the proper voltage levels and adjustments for the different rails of the systems we were designing. So, like I said, the input voltage on anything I normally worked on the AC side was pretty much standardized by the country it was being sold in. So I didn't really have to worry about that kind of AC voltage. So I mostly worked with DC between up to about 48 volts. Some stuff ran on 48 volts, but not much more than that. I mean, I've worked on lights and like LED lights that use capacitive droppers, and that's not technically high end DC current. That's more like choppy DC current. Yeah, that's not good. I don't like to make sparks. All right, hour and a half. It's going for a 30-minute stream, and I've streamed for an hour and a half. That's great. Oh, almost an hour and a half. So, I hey, did Micromage leave? I think he did. I wonder, since the new boards don't use these ESD things, like the new boards don't use these, can I just rip that off and not care? Yeah, that's fine. You think I could just rip these off, Phil? Because the new boards don't have it. I don't know. Wonder if it would work. That is interesting. And yet, my son is not up with the Switch yet. I was hoping he was going to wake up soon so I could plug the Switch in out here and do a test stream of the gameplay, but I will have to do it. Yeah, I'm going to try it. Yeah, possibly. I mean, they don't use it on newer boards. Why? I mean, they decided not to use it anymore, so the circuit looks identical to one without the chip. I mean, the new board even still has the location for it. I mean, if you look, the new board has the location for it. That's what those pads are. So I wonder if I could just pull them. I mean, oh, that's weird. So, doesn't work now, so it can't hurt anything. So, I plan on having a stream on November 30th. It's my birthday. I plan on having all my parts come in, should be here by then from AliExpress. Some tools, some new gizmos and gadgets. I plan on showing you guys. I plan on doing some more repairs on this switch here. I plan on doing that LCD connector, that USB port, that trace repair on P13 if Phil shows me how to do it. Phil. So I plan on that. And I have some other things planned too for that stream. I'm going to try to make it as long as possible. I'm going to come out here. I'm going to put the heating pad on my knee. And then I'm going to try to stream as long as I possibly can on the 30th of November. So I'm going to be doing a lot of different things. So I have a lot planned. So be sure to check that out. It's November 30th. It's Thanksgiving here in America next week, and my son's out of school and he wants to play Borderlands 2 all week. So I'm going to try to stream that. I was hoping he would be up by now before I could test it, but he's not. So
I will figure it out, and may do a test stream later today, and just to see if it works. And then when we play in the morning, I will stream some of it. It'll be me and him playing, just messing around, having a good old time. So thank you guys so much, and I hope everyone has